Okay, so now we're going to look at special products. So first, difference of squares. If you have binomials, okay, two binomials, so first and second terms are the same, but one of them has positive sign between those two terms, and the other one is negative sign. So if you multiply this, if you FOIL this, you end up with a square minus b square. So let me do it here. So a times a square. A times negative b, negative ab. B times a, positive ab, and b times negative b gives you negative b square. So as you see, these middle terms are gone. You end up with a square minus b square. So when you see a plus b, a minus b, so directly you should use the shortcut. Okay. So let's say we have x plus 3, x minus 3. Again, without doing the FOIL, just apply the shortcut. So take the square of the first term, x square, then subtract. So take the square of the second term. 3 square is 9. Okay, so let's apply again the shortcut. It says also always use the shortcut. Okay, when you see anytime like two binomials, same terms, one with positive, one with negative sign, then always use this shortcut. Again, so we have 2y plus 5 times 2y minus 5. Take the square of the first term, 2y squared. So you don't have to show this step, but I'm going to show it for now, okay? Minus, you take the square of the second term. So you get 4y squared minus 25. Okay, so again, when you're doing this, you don't have to show this step. So you can directly come to this point.
Wait, Mustat, I have a question.
Yes.
You know you did 2y squared, right? Is it
Yeah.
not just gonna be why is it 4y squared?
So when you're taking the square, you distribute that exponent to the number and to the variable as well.
Oh, okay, thank you.
Okay, always do that.
Yeah, I got it. Okay.
Okay, so now we have x minus 4, x plus 4. Again, binomials, two binomials. They have the same first and second term, one with negative sign, the other one with the positive sign. So you take the square of the first one and subtract square of the second one. So you get x squared minus 16. You can directly write this, x squared minus 16. D, 3k minus, so square of the first term, 3k squared minus square of the second term. So you get 9k squared minus 49. Again, we are doing the same thing here. Distribute the square to the number and to the variable. Next one. Are we all here? Internet is gone for a while. Yes? Okay, then I continue. So today is something wrong with the internet. We have 6x minus 5y times 6x plus 5y. So square of the first term minus square of the second term. Again, so when you are taking the square of 6x, you distribute that exponent to the 6 to the x. So 36x squared minus, and same thing here, you distribute the square, the exponent to the 5 to the y. So you get 25y squared. Okay, so 2a plus 1 times 2a minus 1. So square of the first term minus square of the second term. 4a squared minus 1. All right, so that is about difference of squares. So we call that difference of squares. Okay. So now we're going to look at perfect square trinomial. So if you need to take a square of a binomial, so let's say you have a plus b squared. So the shortcut would be square of the first term, take the sign between those two terms, give it to this sign as a sign, use it as a sign of the second term here. Okay, then you multiply first and second term and you multiply those by 2. So you get plus 2ab plus square of the last term. If you have a minus b squared, again, the shortcut would be square of the first term minus multiply first and second term, multiply those by 2, plus square of the last term. We're going to now use shortcut to expand these. Okay, so we have x plus 3 squared. So it is like a plus b squared. The square of the first term, x squared, plus 2 times first term times second term, plus square of the last term. So you end up with x squared plus 6x plus 9. Later on, as you use this, actually you're going to skip this step. Okay, you can directly do, okay, square of the first term, x squared, plus multiply first and second term, x times 3, 3x, times 2, 6x, plus square of the last term. As you practice, you don't need to use this step. You can just directly take the square like that. Okay, 2x plus 5 squared, square of the first term, plus 2 times the first term times the second term, plus square of the last term. We get 4x squared, then 20x plus 25. Again, later on, you're going to skip this step. Square of the first term, 2x squared, is 4x squared. Multiply first and second term, 2x times 5, then x times 2, 20x. And square of the last term. Now we have x minus 2 squared. It's like a minus b squared. Apply the shortcut. Square of the first term, x squared. Then minus 2 times the first term times the second term, plus square of the last term. So you get x squared minus 4x plus 4. 4x minus 7y squared. So square of the first term minus 2 times first term times second term plus square of the last term. So you get 16x squared. So 7 times 4, 28 times 2, 56 minus 56xy plus 49y squared. Okay, so 5x plus 3y squared, 5x squared plus 2 times first term times second term plus square of the last term. Okay, so 25x squared. So 5 times 3, 15, times 2, 30, 30xy plus 3y squared gives you 9y squared. 7c minus 4d squared. Again, square of the first term, 7c squared, minus 2 times the first term times the second term plus square of the last term. So that gives you 49c squared. 7 times 4, 28 times 2, 56 CD, and plus 16 D square. So related homework is handout A for this one.